So this is notes number 3, and we're asking the question, is it a solution to a system of linear equations? Here's your learning target for today. I can evaluate a solution to a system of linear equations. So you may want to know, what is a system of equations? A system of linear equations consists of two or more linear equations. I know that sounds redundant, but these two things down here, these are both linear equations, and those are defined by, they make up a line and they have an x and a y. You've seen a lot of linear equations, all the things we did with graphing throughout the, before winter break, for those of you that were with us, were all linear equations. It means they make a line. Here's example 1. This is the problems you're going to see in my math lab. Is -3, 1 a solution to this system of equations? Here's the system. I've got one linear equation here and another linear equation here. So what you're going to do, as we did with the other equation in the last unit, is you replace x with -3 and y with 1. But instead of doing it in one equation, you do it with both. So here's the first equation. You've got x minus y equals -4. So we're going to take our -3 and our 1 and plug them in here and here. So this is what it looks like. There's your -3. There's your -1, and the -4 stays the same. You simplify, and you get to an answer, and in this case, -4 does equal -4, so we find out that's true. So you've got 1 down, now you got to do the other equation. So our 2x plus 10, y equals 4 is right here. Again, plug in your -3 where the x goes, plug in 1 where y is. So it looks like this. Here you go, you've got your -3 in place of your x, and you've got your 1 in place of your y. When you do the math and simplify, you get -6, which is 2 times -3 plus 10 equals 4. If you add those together, you get that 4 equals 4, which again is true. So what that means is when both equations are true with this given point, it means that -3, 1 is a solution to that system of equations. So whenever you plug them both in, if you end up with two true statements at the end, and by statement I mean this and this, it means it's a solution. This is what that means when you look at a graph. So here's a graph of this system. Okay, sorry the colors are off on here. Those are supposed to be switched. But when you graph it, this is what it turns out to be. And that point right there happens to be -3, 1, which is the point we had from our last slide when we plugged it in. So a solution to a system of equations is a fancy way of saying where these graphs meet. So if you're ever going to graph these, the point where they meet is a solution. So let's see what happens with this one. So the next question is 4, 2, a solution to this system of equations. 2x minus 5y equals -2. That's the first equation. Second equation, 3x plus 4y equals 4. Same process. Replace x with 4 and y with 2 in both equations because we have x is 4 and y is 2. Here's the first equation. 2x minus 5y equals -2. We plugged in -4 for x, or sorry, 4 for x and 2 for y. Simplify, which this becomes 8, that becomes -10, that stays -2. And 8 minus 10 is -2, and that does equal -2. So that portion is true because -2 is -2. Next, we move on and we have 3x plus 4y equals 4. Again, same process. You plug in 4 for your x and 2 for your y. Again, we're getting that from right up here what we started with. And that gives me 12 plus 8 equals 4. If you add 12 and 8 together, you get 20, and 20 does not equal 4, so this is a false statement because 20 is not the same as 4. What that means is when we plug them both in and it doesn't make both true, it's not a solution. Okay, if you have 2 false answers or 1 true and 1 false, it's not a solution to the system of equations. Here's what that last slide means. If you look at our two equations again, 2x minus 5y equals negative 2 and 3x plus 4y equals 4, right here is the point 4, 2. It is not where these graphs meet. Where these graphs meet is somewhere over here, and that would be the solution. This is not an answer because it is not where the graphs meet.